and this quantity, the equilibrium constant, becomes equal to 1. So here is a set of values for delta G naught reaction, and here are the equilibrium constants. How did I get this? I got this from okay, so this equation gives me this equation here, but if I know what delta G naught reaction is, if I put in numerical values and assume a room temperature, I can calculate what K is. Here are some values, and you can see that if delta G naught reaction is a very large positive value, K is a very, very small value. Yes, Angela?
For the K equals E something equation, why is the delta S over R instead of like delta S R?
Yeah, because delta H is equal to, delta G is equal to delta H minus T delta S. This T here cancels with this T, and you get delta S naught over R. Does that make sense? So here are some values of delta G naught, and here are the equilibrium constant values. If you have a very large negative delta G naught, then the equilibrium constant is very, very large. That means that pretty much all of the reactants are converted to products. Yes?
Is that equal?
That's,
You want that, right?
yeah.
Okay.
And if you're in a chemical industry, you want a reaction that has a very large equilibrium constant. You want a reaction that has a large negative delta G naught reaction. That means that the reaction is very, very thermodynamically favored. But that doesn't tell you anything about the rate of the reaction. That's something that we're going to talk about later on in the semester when we talk about chemical kinetics. That tells us how fast does that reaction occur. So a reaction can be very, very thermodynamically favored, but it can occur very, very slowly. So that is not good.
Is that like going from like diamond to graphite?
Yes, diamond to graphite, I wouldn't say that it is very, very thermodynamically favored, because the delta G difference between diamond and graphite is small, but it is thermodynamically favored. But it has a huge activation energy outlined over there if you hadn't printed it out. Okay. Can you take a couple of minutes and do this problem, please?
I got into classes.
You register, Sinead?
Yes, there was a knife.
Can I ask you a question about this? But is it like very likely that like, is able to have weight for chem classes?
You get like
Or is it not really?
2 out of 3 out of like the courses that you're on.
Which course are we talking about?
There are 2 habits.
Replacement.
I don't know. We are facing a pretty bad crunch for the upper level chemistry courses. So I would write to the instructor who's teaching that course and put yourself on the wait list.
Or on the 3rd page. Okay.
So you need lecture 20 notes or outline to be able to do this question. I haven't given the quiz yet.
Oh, okay, good.
Okay guys, I'm not going to have office hours today, okay? Because your quiz is today, I still have made very little progress with grading your exams. So I'm just going to spend the entire day working on grading your exam. Because the exam was qualitative, I really have to spend more time and really spend a lot of time looking at your diagrams. And so my hope is that I'll have it all graded by late tonight. So I'm not going to have office hours today. There's no quiz tomorrow, so I don't see any reason why you might be perturbed too much. Okay, please talk to your neighbor and can you try to solve this problem?
Yeah, I always have a, it's on the very front page. Oh, here? This is G.
Oh, that is it. So this should be zero.
That's the
How to that, which is, yeah, it's 2 times negative 237.2.
Okay, it seems as though there are 15 to 20 students in 211 and 205 on wait list for each section. Looking very bad.
Oh, boy. How about you open up a new section?
As department chair, I know what that means. That means I have to clone somebody.
That's not a big problem, right?
Yeah.
I don't know what everybody is wanting to become a chemist, I think now. So I don't know what's going to happen. Okay, so just hang in tough. And the department chair is away, and she's checking emails on and off. She really understands the whole situation in terms of staffing. So it's going to be a couple of days before we sort out this crisis of too many students interested in chemistry. Question, Angela. And the answer is
What's delta? I'm sorry, what's R again?
R is 8.314 joules per mole per Kelvin.
Say that again?
8.314 joules per mole per Kelvin. Oh, I'm just going to tell you the answer, but I'm not going to show you the answer. How's that?
Wait, it's gone.
Yeah, that's why I didn't want to show you the answer. I'm just going to tell you the answer. The answer is 7 times 10 to the power minus 84.
Wait, can you repeat that again?
7 times 10 to the power minus 84.
What's the temperature? It's 98.
298, which is room temperature.
It's,
The value of R is 8.314 joules per mole per Kelvin.
Oh, joules.
T, room temperature, is 298 Kelvin. How many of you got 7 times 10 to the power minus 84? Tiffany, okay.
Got it. No.